Hello everyone. Today let's solve the problem number 40, combination sum 2. So you can just go through the question and you can just try to understand the question with the example that they have given. So I'll just summarize the question so that it will be easier to understand. So what the question states here, we are given an array of candidates. So here you can clearly see we are given an array of candidates and a target sum and a target sum. So we need to find all the unique combinations of the numbers from candidates where the sum equals target. So we need to find all the unique combinations of numbers from candidates where the sum is equals to target. So here you can clearly see 116, that this sums up to the target, right? 6 plus 1 plus 1 is nothing but 8. Same thing goes with the all other things. 5 plus 2 plus 1 is nothing but 8. 7 plus 1 8. 2 plus 6 8. So these are all the valid combinations that sums up to the target. So what is the requirement they have given here? What is the condition? Sorry, each number can be used only once in a combination. So each number we can use only once in a combination, and the result should not contain duplicate combinations. And a result, so suppose if we are having 116, it again it must not, we should not have the array containing the same elements, right? So we should not have the duplicate combinations. So this is the condition they have mentioned. So I hope this is clear. In the example 2, let's consider the example 2 here. Target 5 they have given here. So valid combinations is 1 2 2, nothing but 2 plus 2 4, 4 plus 1 5, and 5. So these are the valid combinations, right? I hope this is completely clear. As usual, let's go with the, or let's discuss the approach, right? So I'll just get to know the approach and then finally discuss the edge cases and write the code and discuss the complexities of the code that we have written. Initially, let's go with the up. So here we'll be using the backtracking to explore all the possible subsets that sum to the target. So just keep this in mind. We'll be making use of the backtracking. This is fine. The next step is, how we will use, let's see step by step. So first is we will be sorting the array. So let's sort the array initially. This is the first step. We have to sort the array. Means this basically helps in avoiding the duplicate combinations. So that is the reason we are sorting the array. Why we are sorting the array? This helps in avoiding duplicate combinations. This we have to keep in mind. Second step is use a recursive function. We'll be making use of a recursive function. So why we'll be making use of the recursive function here? Because we have to add an element to the combination if it doesn't exceed the target. So here it adds an element to the combination if it doesn't exceed target, one thing. And it also skips duplicate elements, nothing but it avoids the multiples, right? So that's why we'll be making use of the recursive function. And one more thing we need to consider here, we have to move to the next index, right? Each time, to ensure that each number is used exactly once. So that we can achieve through the recursive function. And also finally we will backtrack, means we will remove the last added element if needed. So that is the reason we can easily make use of the recursive function. Here in simple terms we'll be going with the recursive backtracking, right? First we'll sort the array, and second step, as I've said, the 4 steps, right, we'll be making use of the recursive function. Means first, why recursive function here? Why we are making use of the recursive backtracking here? Because it adds an element to the combination if it doesn't exceed the target. Second thing is we have to skip the duplicate elements. It does by avoiding the multiples. So third step is it moves to the next index because we have to ensure each number is used exactly once. That is one thing. And final thing is it also backtracks, means we have to remove the last added element if needed particularly, right? So this is the approach that we'll be going with. So let's consider all the edge cases. Let's discuss all the edge cases, then write the code. Here, let's discuss the edge cases one by one. Just give me a second here. So the first edge case that we are dealing with here is duplicates and candidates. So suppose if we are having the duplicate numbers in the candidate, so I'll just consider candidates as C. Let me consider duplicate elements with an, so 2, let me consider this one, right? So we have duplicates for 2 right here. So one thing, and target, let me consider here 5. Output will be in this case 1, 2, 2 and 5. So these are the valid combinations that we get. So we have to avoid duplicate here, right? So in this case, avoid duplicate. We have to avoid the duplicate 2 to 1 in this case. So this is one of the edge case, nothing but the duplicates in the candidates, right? This is first edge case. This one, duplicates in candidates.
First condition, right? The second condition here is this one, or but greater than target. So I'll just figure out the condition. All elements are greater than target.
So here we are going with all elements are greater than target. So just give me a second here. So this is fine. Let's consider the example. Let me consider this one here. So let me consider the example. So here all the elements has to be greater than target right here. So I'll just give 9, 10, 11 in this case. So target, let me give 5 in this case. Output will be empty array. So here no valid combinations found at all, because all the elements are greater than the target. So there will be no valid combination. In this case, we'll be displaying empty array as output. So let's move on with the third edge case. Nothing but multiple ways to reach the target, but duplicates exist here. So here let me give multiple ways to reach target, but still here duplicate exists. I'll just give here, but duplicates exist. So this is fine. This is for the third edge case. Let me consider the input here. 10, 1, 2, 7, 6, 1, 5. This is fine. This is for the candidates. And target, let's consider 8 here. So the output will be here 1, 1, 6. We have the duplicates here. This is one thing. 1, 2, 5. This leads to the this sums up to the 8, and 1, 7 we can consider. This is one thing. And finally 2, 6, right? This is also one of the things. So we have to avoid the duplicate sets here. So this is fine. This is for the condition multiple ways to reach the target, but duplicates exist here. This is fine. So this is for the third edge case. Let's move on with the fourth edge case. Nothing but minimum input size. Here this will be minimum input size. When I say minimum input size, this candidates will be here. Candidate, let me consider 1, and target, let me consider 1. So the output will be 1 itself. This is fine. So we have only one element. So that sums up to the target 1. So the output will be 1 here. That combination we are just displaying in the form of output. The final one is large input size. So when I say large input size, example, let me consider candidates here 1, 1, 1. This is fine. Let me consider this one to 100 times here. This is fine. Just in case, this is for the large input size. Suppose target is 30 here. So output, this has to, let me just give here, should handle efficiently, because we have to handle the large input size efficiently, right? So this one I'll just give here just for the example sake. Should handle efficiently. So what are the edge cases that we considered here? First one was for this one. Just give me a second here. Duplicates in the candidates, you can clearly see. This is for the duplicates in candidates. Second one was for the all elements are greater than target. And third one was for multiple ways to reach the target, but duplicates exist. We saw, right? This one. Fourth one was for minimum input size. Fifth one was for large input size. These are the edge cases that we need to consider or keep in mind. So next, let's write the code, and I'll just explain the code while writing the code itself, and then finally discuss the complexities of the code that we have written. Now let's write the code here as we had discussed in the approach. First, we are sorting the array to handle the duplicates easily. So I'll just give here, we have to sort the candidate array right here. Let me consider this one. Sorry, this one dot sort I'll give. We're sorting in ascending order. So I'll just give here A minus B. This is fine. So the next step is we have to store the final result. So I'll just give here result equals this one. This is fine. Next step is we have to define the backtracking function. Let's make use of the ify function here. I mean ify immediately invoke function expression, right? I'll just give here backtrack in this case. This one, let me pass the parameters T, S and combinations. So this is fine. So we are just defining the backtracking function here in this case. So within the backtrack function, if the remaining target is 0, we have to find the valid combination, right? So if the remaining target that is equal to 0, then we have to find a valid combination for that. Then we will return result.push of combination, right? We'll be making use of the spread operator in this case. So I hope this is clear. Next step is we have to iterate through the candidates array. So I'll just give here for let equals 0. Sorry, we have to start from s, I equals s in this case. So candidates, length of the candidates we have to consider, and also iterated value of the candidates. So here this will be candidates of I less than or equal to t, and then finally let's increment the I here. So this is fine. What we are doing here, we are just iterating through the candidates. So after iterating through the candidates within the for loop, so we have to skip the duplicate elements to prevent the duplicate combination. So we have to prevent the duplicate combination. That's what they have asked in the question. So for this, let me write the simple if condition. If I greater than s, and we have to consider the iterated value of the candidates here. Sorry. So what did I do here? So let me copy this one. If I is greater than s and also iterated value of the candidates is equal to previous element. So that one I can just write here I minus 1. Then I'll just give here continue in this case. So we have to skip the duplicate elements to prevent the duplicate combinations. We have sorted the array already. So suppose if we have the previous element as same, then we are just skipping that one. So that is the reason I have made use of the continue here. I hope this line is completely clear, right? So next we have to choose the element, right? For choosing the element, I'll just give here combination dot push iterated value of the candidates. Nothing but here this one candidates of I. I hope this is clear. So what is next step then? Here in this case, we have to recur with reduced target and next index. In this case, I'll just give backtrack of t minus iterated value of the candidates along with next element I plus 1 and combination COMB I have considered right here. Can clearly see here parameter within the backtrack function. This is fine. We are just considering we have to recur with a reduced target, right? So t minus candidates of I, and also the next index. Next index here I have considered here I. So next index is I plus 1. So this is nothing but t minus candidates of I. This is nothing but we have to recur with reduced target. Nothing but t minus candidates of I. So this is next index. So and we have to consider next index nothing but I plus 1. This is combination, right? So I hope this is clear. The final step here is we have to backtrack. If needed, we have to remove the last element. Nothing but we have to backtrack. So I'll just give here combination dot pop. So I hope this is completely clear. So as we have made use of the ify here, so we have to use parenthesis here along with, let me give here target, we are backtracking from 0 initially, and the empty array. So this is fine. Uh, hmm, the final step is we have to return the final result. So in our case, it is I have made use of the res, right? So we'll just return the result array here. This is fine. So let me format this one once and hit the run button. So you can clearly see the sample test case is getting passed here. So let me hit the submit button as well. So now all the test cases are getting passed. So the code works absolutely correct in our case. So let's quickly discuss the time complexity and the space complexity of the code that we have written. The approach that we went with here is this one, recursive backtracking with sorting. You can clearly see, or you can just call it as backtracking. Right. So the approach that we went with here is backtracking. And what will be the time complexity here? The overall time complexity would be 2 to the power of n here in this case. So why it is 2 to the power of n? Because we are considering exponential in the worst case, right? So it is 2 to the power of n. So what will be the space complexity here? The overall space complexity would be big of n. So we are dealing with the recursive backtrack. We are going with the recursive backtracking, right? And we know that recursive stack depth can go up to n. So at the worst case, so the overall space complexity would be big of n. So the time complexity would be here big of 2 to the power of n, and the space complexity would be big of n in this case, right? I hope this is completely clear. So for now, I hope the solution is completely clear now. So for now, this is it. Thanks for watching, guys.